The hair follicle is a complex skin appendage consisting of 6 concentric cylinders with several distinct cell types that produce highly specialized proteins. The continuous cycling of the hair follicle through its distinct growth stages makes the appendage suitable for targeted gene therapy, which can potentially correct baldness and loss of hair pigmentation. In this video, we demonstrate a method for the histoculture of hair-growing skin and ex vivo transduction of hair follicles with green fluorescent protein. This efficient transduction technique is useful for following the promoter activity of various genes of interest in various regions of the follicle throughout its growth cycle.
My name is Robert Hoffman. I'm president of Anti-Cancer Inc. Today we're going to show you very powerful procedures for hair follicle gene therapy.
This protocol starts with the histoculture of skin, followed by collagenase treatment. First, mice are sacrificed 6 days after depilation, and the back skin is removed at the level of the subcutis. After removing the skin, the subcutaneous tissue is removed. The skin is then rinsed in calcium and magnesium-free PBS. At this point, the dissected skin is transferred to medium. Following PBS rinsing, skin samples are cut to small pieces, approximately 1 millimeter cubed. A fraction of the specimens are set aside and cultured in RPMI 1640 and 10% fetal bovine serum as untreated controls. The rest of the specimens are incubated in 2 mg per ml collagenase solution in RPMI medium for 45 minutes to 3.75 hours at 37 degrees. Digested specimens are then washed in calcium-magnesium-free PBS. Histocultures can be infected with virus for GFP transduction now that collagenase has made the hair follicles more accessible to virus. In order to induce hair follicles to express GFP, they are first infected with virus. Adenovirus carrying a GFP plasmid is then added to the collagenase-treated skin histocultures at 2.4 million to 5 billion plaque-forming units per mil. Following the addition of virus, they are now placed in the incubator for 1 to 6 hours. After viral transduction of GFP in skin histocultures and approximately 24 hours after harvest, the specimens can be grafted on either nude or C57 black 6 mice. GFP expression can then be assessed using fluorescence microscopy performed either on histocultures or visualized in vivo on grafted skin. In order to determine the efficiency of GFP transduction, the total number of hair follicles and GFP-positive hair follicles are determined under bright field and fluorescence microscopy. 5 randomly chosen microscope fields covering an area of 0.581 millimeters squared are analyzed for GFP expression. At least 500 hairs per specimen are counted to generate the percentage of GFP-positive hair follicles. Hair follicles in which GFP is visualized anywhere in the hair bulb or shaft are scored as GFP positive. We have just shown you a highly efficient method for the transduction of GFP in hair follicles, which will be extremely useful for gene therapy. Such knowledge is of clinical importance because it has implications for curing alopecia or baldness, preventing chemotherapy-induced alopecia, and permanently modifying hair color.
Thank you for watching, and good luck with your experiments.